Alright, welcome back everybody. In this video we're going to talk about calculating slope, which is a concept I'm sure you've all seen many times before. We start with just the definition of the slope formula. If we want to find the slope of the line through the points x sub 1, y sub 1, and x sub 2, y sub 2, we just use the formula that slope is equal to quantity y sub 2 minus y sub 1 over the quantity x sub 2 minus x sub 1. So really, all we're going to do is we're going to take one point and put it into this formula, and take the other point and put it into this formula, and subtract the coordinates of those points. And that's how we're going to calculate slope. Now, it really doesn't matter which point we choose as x sub 1, y sub 1, and which point we choose as x sub 2, y sub 2. The order that we put the points into the slope formula is completely unimportant as long as we do two things. Number one, the y's are in the numerator. Okay, that's the first thing that we need to make sure that we do when we set up our slope formula. The second thing is we need to make sure we vertically line up the coordinates from the same point. So no matter which point we choose as x sub 1, y sub 1, and which one we choose as x sub 2, y sub 2, those coordinates from the same point should line up with each other vertically in our formula. Okay, so let's use the slope formula to calculate some slopes here. We've got slope equals, and I'm going to use negative 2, 4 as my second point here in the formula. So I put the y coordinate in the numerator, the x coordinate in the denominator. I do the same thing with the other point. I put the y coordinate in the numerator, I put the x coordinate in the denominator, and then I subtract those. And then I go ahead and do the calculations, and that gives me negative 3 over negative 5, which, since I have a negative divided by a negative, I'm going to simplify that to just positive 3/5. And that's my slope in my line through those 2 points. I'll do the same thing in part B. This time I'm going to choose the first point, put in my formula first, and put the y coordinate in the numerator, the x coordinate in the denominator, and do the same thing with the other point, y coordinate in the numerator, x coordinate in the denominator, and then I subtract. Now here I'm subtracting away negative numbers, so I'm going to make sure that I just add the positive value of that number. So I've got negative 2 minus negative 6, that's going to give me 4, and 5 minus negative 3, that's going to give me 8. And what I should always do when I have a slope like this is reduce it. 4 over 8 reduces to 1/2. And that's my slope. Okay? Side note, I mentioned to you that the order we do them doesn't matter. If I had done this in the other direction, I put the negative 6, negative 3, put the coordinates from the point negative 3, negative 6 first, and the coordinates from the other point second. Here's what would have happened. I would have had negative 8, pardon me, negative 4. Got ahead of myself there. Would have gotten negative 4 over negative 8, which, again, since they're both negative, is positive 4/8, which reduces to 1/2. And we end up with exactly the same value for our slope. So it doesn't matter the order that we put them in, as long as we follow these two ironclad rules. Alright. Next problem, a little example problem. The population of Boomtown increased by a constant amount each year from 2002 until 2015. In 2002, the population was 47,682. In 2015, the population was 63,906. How much did the population increase each year? Now, the way this question is asked, we're looking for population each year. And that tells us that when we set up the slope formula, we should have population over years. Okay, so first I'm going to get the information for one of these years. Usually when I'm doing one of these, I start with the later year. So I'm going to start with 2015, and the population is 63,906. And that's going to be the first thing that goes into my slope formula. Put the population in the numerator, and I put the year in the denominator. And then I do the same with the second point. The second point is for the year 2002. Population was 47,682. So I put my population in there. And I put my year in the denominator. And now I'm going to go ahead and calculate some things. 2015 minus 2002 is going to be 13 years. And I'm going to break out my handy-dandy calculator here for the other calculations. And the population difference, 63,906 minus 47,682, 16,224. And then to find my slope, I'm going to take that 16,224 and divide it by 13, and we get 1,248, which means that the population increases. Remember, when we set up this fraction, this was people over years, so the slope here is 1,248 people per year is the change in the population. All right, one more example related to slope. This question asks, what's the rate of change in the following function? And that's something that you should understand, is the connection between the phrase rate of change and slope. When we're talking about the rate of change of any linear function, what we're really talking about is we're talking about the slope. So when we want the rate of change for this function, we're looking for the slope of this function. And I'm going to do this in kind of a weird way to start. I'm just going to pick a couple of points. I'm going to put 2 in here for x, and if I put 2 in here for x, the y value is 3. And then I'm going to pick another point, maybe I'll put in 5 for x. And if I put 5 in here for x, the y value is 15. So I just randomly picked, a couple of x coordinates, substituted them into the equation function for x, and then figured out the y coordinate that came with them. If I find the slope this way, I've got 15 over 5, line those up, and I've got 3 over 2, line those up. I do the arithmetic, and I get 12 over 3, which reduces to 4. So 4 is the rate of change in this function. Now, how could I have done that a lot easier? Well, we have this function, and it's already in the form y equals mx plus b, which many of you should recognize as slope-intercept form, and we're going to talk about that more in a later video. But I could have just looked immediately at this function and looked at the number that is the x coefficient, and that would have told me the rate of change. All right, everybody, that's the end of this video on calculating slope. See you next time, and have a great day.